Okay, cool. Thank you. Hi guys. So that was a fantastic introduction, nonetheless, by Poonam. Uh, nice. So she said the right thing, the right sort of phrase or the statement, the blanket statement that a lot of people have is it's a passion project thing. Flutter is something that you use to build private apps or personal projects rather than you use to build enterprise scale applications, right? That's what we are here to talk about, right? Flutter at scale. So building apps that glide. Glide is an app that we've built with Flutter here at Quicko, right? Right now it's live on App Store, Play Store. You can go and explore it out. We'll get into the details here, right? So yeah, a quick introduction, right? My name is Nachiketa. I work, of course, here at Quicko. And then this is my Flutter tag. I've been doing Flutter since 0.10.2. So that is anyone knows what year is this? Like 0.10.2 ka? This is before 1. Okay, so I got 17. So 17 is right. They launched it in 2014. Then up till 2019, 2018, 18 was the first 100 release, right? So I got sort of introduced at a GDG meetup, not unlike this, and that's what sort of hooked me onto this path, right? Just a quick sort of introduction of Quicko, right? It's important to understand because you are. So I am here to talk about the app that we built, and we're going to talk about in context of taxes, right? So it's important to understand what Quicko does, right? So we are primarily a tax platform, right? What we have here is sort of how we like to represent ourselves, right? At the heart of everything we do is Sandbox. It's a subsidiary of Quicko. It's essentially APIs, right? So really good, well-written REST-like APIs at the heart of everything we do. The second layer is the products that we build on top of those APIs, right? So Glide, essentially what I talked about, are web apps that you interact with on your browser. All of that comes onto the product layer, right? Again, built on top of these APIs. Then we have our services, right? So advisory, tax advisory. How many of you have a CA or have talked to a CA, right? How many of you have filed taxes actually? Okay, nice. A lot of people, right? So there's a side goal is to get you to Quicko to file taxes of the stock as well. But yeah, so that's tax advisor. If you don't want to do it yourself, right? Come to us. We'll connect you with an accountant and with a chartered accountant and help you out with that. And then we have content around it, right? So that circle, everything that's inside the circle, we build and publish content around it, right? Cool. Right. So today, what I want to do essentially is sort of pose 3 questions or 3 problems and answer them one by one, right? Each of these 3 problems is at the core of how you build an application, right? That works for a lot of people. So first problem is structure, right? Okay, a confession. I have about 8 to 9 GBs of just random projects that I've built and not completed. Who's in the boat with me? Right? 8 to 9 GBs, nahi, but as I come, cool, right? And if you go back and look at those projects now, or if you try to pick those projects up, one of the things that you'll encounter is ये क्या किया है मैंने, right? What was I thinking at that point, right? Because it's impulse, right? When you sort of learn, when you keep on learning, and when you keep on evolving, you feel whatever you had done was trash, right? Or you don't too kindly at it. So essentially, structure is important, right? Having a structure that scales, having a structure that makes sense to other people. And again, this is a large scale app, right? What's a definition of a good definition of large scale app to keep in mind is there's probably code that you haven't seen or that you don't know, right? That's a good definition of a large scale app, right? In a private app where 2 or 3 people are building it, you probably know the entire code base, right? In a larger app, there are again pieces of code, caveats, so आपको surprise मिलता है कि ये किसने छोड़ा इधर. But that's essentially the first problem, structure. We solve that using architecture, right? A really good, solid architecture, right? Again, we'll come to that. The second question is state, right? It's such an overloaded word, state, right? But whenever I talk about state, just imagine what I mean is data and how it changes over time, right? That's essentially what state is. So any data that your application has, and then through user interactions, right, through API calls, through anything, how does it change over time? And we are going to solve for that using orchestration, right? So how do you orchestrate pieces in your code so that your sort of data changes are something that makes sense and then they don't break your app, right? And the third thing is screens. ये मैंने screens इसलिए डाला, alliteration अच्छा हो रहा था SSS का. But essentially what I mean by screens is UI, right? So how do you build UI that scales? Of course, Flutter is a UI library, right? At the end of the day, what you really want is the ability to really quickly build and ship apps, right? So how do you then solve for screens? The answer is abstractions, right? Cool. Let's then dive thoda into it. The first part, of course, is structure, right? Now, before we sort of start, through a structure where I am coding and I want to add tax payments as a feature onto my application, right? And through that, we'll understand all these three things, right? We'll understand structure, we'll understand what was the second thing? Very good, thank you. State and then screen. Absolutely, cool. So essentially what I'm going to do is build pieces of code, right, that facilitate tax payment for an individual, right? Okay. So structure mein it's all layers, right? You'll hear this word a lot of times, layers, abstractions, right? It's really important because Flutter itself relies a lot on these sort of fundamental concepts, right? But then there are three things again. I like three, the number three. But then there are three things again. The first layer is the data layer, right? The data layer is essentially all about where your user ka data lives, right? That layer is responsible for interacting with that data, whether it be remote or in a local store, right? Whether it's on a server, whether it's on a DeFi app, anything that sort of comes in or goes out of your app, right? Has to go through the data layer, right? So there are two constructs there, providers and stores, right? You might have heard these terms again. You might think this is not the provider that Remy wrote. This is different, right? This is a data provider. Yeah, but so providers and that word, it's an abstraction between your application and your data, right? It defines a standard set of contracts that your UI layer, right? There we are going to use the right layer, right? Which is I'm assuming a lot of us have also worked a lot with. The presentation layer is primarily everything that the user sees and interacts with, right? And there we have pages and qubits, right? Of course, we have widgets, it's all widgets. But these are the sort of constructs that we are working with, right? Cool. Okay, this is the code I was talking about. Right. So let's quickly understand providers, right? And then, of course, as I discovered, this is actually code abstracted, but actually code that was written into applications that we've built, right? Of course, it's sort of pseudo code kar diya hai maine, so like I can't display 1,000 lines of code here, but this is the essence of it, right? Now, a quick question for my friends at the back: is it visible or should I zoom in? Perfect. There'll be some slides that is slightly bigger. So अगर नहीं हो तो मेरे को बोल देना. I can zoom in periodically. Right? Cool. So we start with providers, right? So again, like I said, providers interact with anything that's remote. In this case, I have a tax payments gateway provider, right? Now, what does this mean? To make a tax payment, right? What I need to do essentially is to tell the server to request a payment from the user, right? उसके बिना tax payment कहाँ से करोगे, right? So one of those methods I've written here is post collect pay request, right? Collect pay is a sort of technical term that you might hear in UPI, right? So whenever you go and enter UPI ID somewhere, right, on Amazon or on Book My Show or anything, you enter your UPI ID and you enter, and then 5 minute का timer चालू हो जाता है, if you remember, right? So that process is the collect pay thing, right? So you have to go to that particular UPI app and then make that transaction, and then there's a callback that happens, and that the payment is collected, and then that state changes, right? So that's what we are doing. It's a simple method that returns a map or string dynamic. It takes in a map with the request. This request could be the user ka UPI ID along with some other identifying information we might want, right? Then you are doing client. Again, this is abstracted. So client is any API client that I use. You can use DO, you can use plain HTTP, anything, right? And I'm posting a request to a particular thing, right? Now, this is important. The base URL I'm accessing from environment, right? Any reason I might want to do that? Like, why not just write the domain here, like api.quicko.com/this? Security, okay? Good suggestion. Sorry, I heard flavors. Yes, I heard flavors. Exactly, flavors, right? If I am testing my app, I do not want to do it in production. कभी-कभी करना पड़ता है bugs के लिए, but still, when I'm building my apps and actively building a feature, I really don't want to use product. Deploy भी नहीं हुआ, right? क्या use करूँगा मैं? So environment is that again that abstraction that sort of gives me whatever API I need, right? From my environment. Now that could be again Dart, env या कोई भी package that you use, right? Cool. Then I just make a post request, encode that body, and then again this is a utility class that I've built, right? So again, every API at Quicko has a structured response, right? That structured response is encoded into the API response class, right? What you can do is it's typed, right? It's typed over a generic type. So you can pass that type and it will convert it and then send that response back. And you can call the build method on top of that, right? What this does is also it handles all the errors, right? So it's essentially imagine a switch case written there with all the response codes and then well-defined exceptions being thrown whenever we encounter those errors. And agar 200 aega, to 200 pe, this will give you back the data. Make sense? Cool. Then quickly we have another method down there, health info karke, right? Get health info karke. Now, do you see a difference between these two? Like it's subtle. I'll tell you, it's not in the it's in the signature part of the method. Like, क्या difference दिख रहा है? Okay, return type is of course one thing. Now you might just mean कि मैं अलग-अलग चीजें कर रहा हूँ, right? Return एक मैं map कर रहा हूँ एक में. But the thing is कि one place I'm returning a primitive, right? A Dart primitive. Another place I'm returning a really typed object, right? Which is a class that I've built out. Health info जिसमें जो भी properties होगी वो health check की होगी, right? Now I have a question for you. What should you use? Should you return primitives from this provider layer, or should you return well-typed objects? Okay, chalo, raise of hands. Primitives. Okay. Okay, for third party yes, and typed objects. Okay, बाकी सब नोटा वाले. Cool. Both was also an answer, right? Again, okay. So that depends on your requirement, right? Like everything, it's not binary, right? We at Quicko prefer returning typed objects, right? Primarily because we have shared libraries, right, that use providers. So each provider can use by multiple applications. But both of those work on the same contract, right? Both of those expect health info ka data, right? But if you have a library that other people are going to use, right, or is going to be used for sort of a random API call that could return any data, of course you have to return primitives from there, right? Cool. One more provider, right? This provider I put in just to sort of help you understand some other constructs, right? So class, and then I have a base URL, right? This is again just cleaning up your code a bit. That base URL I can declare the constructor, right? And then every subsequent call I can just use that base URL and uske upar build on top of it. This is really good when you have, who has heard of API gateways? Like, do you know what API gateways are? So it's AWS ka construct, right? It's where you have listed all your endpoints, right? A good practice that I find is that you build a provider to correspond with an API gateway, right? Sometimes it might feel too overwhelming. So again, you can split your code into different parts, but it's a good mental map, right? And what you could do is have a base path of that gateway as your base URL, and then all your subsequent requests would make sense, right? So this method is simply getting all the tax payment a user has made, right? So it will return you a list of tax payment, right? Again, we are building the API response and sending it back. Okay, this is one of those sort of smaller codes that I was talking about. Cool. I think I'll need to zoom in a bit. Which can I? Okay, is it visible? You guys can see it? Thoda? What? Okay, I'll walk you through it. Don't worry. Okay. So this is a store, right? Now again, when I say store, lot of loaded and baggage onto that word, right? Store could mean a lot of things. When I say store here, I'll always and forever refer to your local store, right? Now, we again have multiple stores for multiple things, right? So again, going back to one of those things that I said about the one-liner pitch. Does anyone remember Glide ka one-liner pitch? Save, pay, file, and track taxes, right? That's the pitch, right? Now, save, pay, file, track is not just the pitch; those are the modules inside the app, right? There's a save module, there's a file module. Each of them sometimes have different data, sometimes have similar data, right? So what we have here is an abstract class, right? It's a store class, right? That defines certain methods, right? Again, abstract class ka concept pata hoga. There are certain implemented methods, there are certain non-implemented methods, right? What's interesting here is the signature of the class, abstract base class store. Does anyone know what the base means? Dart anyone follows? They recently came out with class modifiers, right? They introduced a lot of them. They introduced sealed, they introduced final, they introduced base, right? So anyone knows what base class means? Okay, that's fine. So again, we'll quickly look at another store after this, someone that implements this store, and through that understand what base would do and final would do, right? But this store kya karta hai? It takes in store name karke, there's a well structured enum, right? Again, avoid using dynamic types and strings, right? I can't stress this enough. एक fat fingering या एक typo की वजह से just इधर का data उधर चले जाएगा, right? And you will create random stores, right? Or you will try to access stores that don't exist, right? So use enums, right? So there's an enum called store name, right? So it accepts it in the constructor. What it does, it initializes a Hive box, right? Anybody use Hive? Okay, cool. So Hive is just a library, right? It's used to cache data, right? What it does is it writes to the disk, but advantage uska ye hai ki it gives you synchronous reads, right? Which is really important when you want to build a good UI, right? Async reads mein you have to wait. भले वो 1 millisecond का wait हो, that operation or that interaction doesn't make sense, right? So sync reads that the way it does it, it loads that file into the RAM. It's really cool if you want to check out Hive ka behind the scenes. But then it initializes a Hive box, right, with that store name, and then we have some standard methods on top of it, right? We have write, read. Again, write is happening with a type, right? You can write any type to it, and then it accepts a store key. This is again really important. Store key is an enum. Use enums, don't use strings, right? But that's where you also get a registry of everything that you are storing in the store key enum, right? So you know anything outside of it isn't being randomly stored, right? Now let's look at this is good. This is a bit bigger. Now let's look at a tax payment store, right? So this is gonna go and extend the store. So that store ka sara capabilities are now onto this tax payment store. Of course, we were expecting a store name, right? So I'm gonna give I'll call the super constructor and give the store name. Again, this is still the store or the data layer, right? Nowhere the UI has to come in and deal with the complexity of kya store kahan pe kyun initialize karna hai, right? My data layer itself is taking care of it, right? So मेरे UI पे या presentation पे जाके मेरे को ऐसा नहीं बोलने का कि अच्छा मेरे को file में जाके tax payment store या इधर जाके वो store चाहिए, right? You initialize the class and that's how it sort of works. Okay, then store के ऊपर there are wrappers around those primitive methods, right? So again, this is another layer of abstraction. I don't want you to directly use these methods. What I want is an implementation that writes a specific type, right? Again, what's the advantage of this is you don't get unnecessary or random data written. You know exactly what you are writing or reading, right? And that is achieved through sort of store keys inside the right method. But then again, वो चीज abstract हो जाता है to these guys, right? Whoever uses tax payment store doesn't have to worry about what key, kya key, what key management, right? All they have to do is call write tax payment method, right? Or the generic and everything sort of gets abstracted. Okay. Then there's a getter. Now this is semantics, right? You might say, okay, why is there a method for write and a getter for reading data, right? Anyone knows what's the difference between a getter, or when should you use ideally a getter and a method, or a method? Okay, private variable, not exactly where I was going, but good attempt. Anyone else? So, in semantics, that ke getters are evaluated when you request them, right? So you can use getters, but parameters kahan se pass karoge, right? When you want to select a particular thing from a list of things, you might need parameters, right? That's when you use methods. For us in stores, it makes a lot of sense to write getters because usme generally you don't want to select any particular kind of things at this layer. So we just do tax payment store, and uske instance where you do tax payments and you get all the tax payments you need. Make sense? Okay. Another fun important bit. You see all these methods, write, read, delete, are protected. That protected annotation, what it does is it disallows implementation or call of that, right? Outside any extending class, right? So let's say I create another store that extends tax payment store. I can't use write udhar, right? Because it's a protected member, right? So again, that's what I want. I don't want people to go and do those writes. Cool. Again, just a quick distinction. I'm using the final method here. I have to use the final keyword because the class that I'm extending is a base class, right? Without going into too much detail, if you want to again Dart ka specification padna, it's really fun. Without going into too much detail, what this says is if you have a library or if you have an external package for all your stores, right? Final says that no one can extend tax payment store. No one can build on top of its functionalities, right? The language, the framework itself will disallow it, right? So it's a good way to sort of prevent unwanted mutations on your classes, right? Then quickly coming to repositories, right? Repositories, you can think of them as again interfaces that provide a standard contract, right? So what do I mean by standard contract? So let's say tax payment repository is a tax payment. I had two providers, right? Tax payment gateway provider and tax payment provider, right? I have a single repository, tax payment repository that can interact with those providers. So my UI only has to worry about interacting with the tax payment repository, right? Now in this case, there's just some methods, right? There's a getAll method that gets providers a tax payments. It stores it in the data and then it returns whatever it found, right? So again, I'm delegating storing of the data, all that business logic to kya store karna hai, kya nahi store karna hai to the repository, right? So when the client makes a call, it does not have to then go subsequently save that data. By the nature of the call, it knows that it's gonna be cached, right? Then I have, of course, streams. That streams was used, right? You should really check streams out, right? It's a really powerful construct and they've built it out really well. Any data again you want to observe, right, that changes over time and react to it, streams are a really great way to handle it. Broadcast, multicast, all those things, right? But again, my store has a watch method just I can pass a key and then it will watch that object for me. It will return a stream, right? And that stream, whenever it changes, I can listen to that, create a subscription and then react to it, right? And then I can have getters, right? Again, this is a contract that I as a sort of developer has defined in the repositories that other people are going to use, right? That contract also says that what's a has tax payments ka matlab kya hai, right? So there is standard contract meaning that of course store में होना चाहिए. So store dot contains की मैंने डाला हुआ है, but then I also mean that it should not be empty. Cool. Then I will quickly go on to state, right? State pay. What I want to quickly discuss is these two screens, right? So this is a screen where sort of the user lands when they come onto the pay module, right? When they click on history, right? That's when I want to navigate them to this state, right? Now here I might not have this data cached, or I might have this data cached, right? So based on that, I might want to take certain actions, right? Very quickly, just looking at the page here. This is a routing mechanism, right? I'm using a stateless widget, right? I'm extending it the auto route wrapper to give it the block provider ka context. We're using block here again. Then I'm saying to my qubit again is a class that manages that state to load tax payments, right? So whenever someone comes onto that page, sort of init hota hai jab wo page, tab I start loading those tax payment, and then this is the part of my UI where I'm listening and reacting to those states, right? Then we have qubit, right? Again, a bunch of code, but I want you to understand the construct, right? What qubit ka load method is doing is it's creating these subscriptions, right? पहले तो it's checking the store कि अगर store में है तो directly emit a loaded state, right? तो दिखाना लगो user को, अगर नहीं है तो loading state emit करो and then start to get all your data, right? So while the user sees loading, you keep on waiting for the data to come, and you can start a stream, right? You can start a subscription to those streams, and वो streams को listen करके जब भी data आएगा, you rebuild your UI with that data, right? And then of course cancelling substreams, really important. Memory leaks होता है इससे guys, right? So always cancel your streams, right? And then screens, right? Layers all the way down. Reference to a book. Again, layers, another word आया, right? Flutter itself is layered. There's a fantastic talk called the Mahogany Train. If you wanna listen to it, it's from way back in 2015. One of the co-founders of Flutter is giving that talk. Talks about all the abstractions that they've built, right? So उनका rendering layer है, right? They have elements layer, उसके ऊपर widgets layer होता है. That's where in our app or in a client app, that abstraction starts. The base thing, right, is the material Cupertino or custom widgets that you have built, right? उसके ऊपर you build base widgets that are you going to use. So again, what am I talking about? I am talking about wrapping all these material widgets to your design system, right? And then उसके ऊपर you build composition widgets, right? What this means is these composition widgets are actually what's gonna show up on your screen, right? But because they have gone through this hierarchy, it's really intuitive to instantiate those, pass parameters to those, change the data of those, right? So what does this mean? This means that this is a card, right, that Flutter provides out of the box. This is a card base, right, that has all the contracts that my app needs, right? A card needs to be tappable, a card needs to show delete options, all those things coded onto this base layer. And then उसके ऊपर composition layer आता है जहाँ पे मैं दिखाऊंगा tax payment card or your tax payment sort of line item, right? And that will have all the goodness of these layers attached with it without the complexity. That's the really important part, right? Again, coming to composition really quickly. So we have a page. That page is made up of fragments, right? Fragments in fact can be made up of widgets, sections, right? So breaking down everything is really important. And the last slide, lessons from pain, right? This is again, there are many lessons, but quickly going through these are the situations I have encountered and have held painful repercussions of them. So I'm sort of saying use these as caution whenever you are developing. So max line limit. I have a strict rule that no file has to be over 350 lines, right? It always makes sense to split your code into smaller and smaller parts, right? You can use part files and extensions for that. Dart extensions are a fantastic invention, right? So use those a lot. Strongly typed, soundly null safe, right? Dart has sound null safety, it has type inference, use that, right? Use the static type nature of Dart. Don't use dynamic everywhere, right? It just defeats the purpose of a wonderful language like Dart. Using static analysis is really important, right? Has a really powerful static analysis engine, Dart. One of my favorite things is this to-do show up, right? Whenever you write a to-do comment, it shows up as a problem in VS Code, right? So target 0 is essentially before going to production, we internally have a target that problem count should be 0, right? So whenever I see bad code or whenever I write code that I know that I want to change, I write a to-do there, right? So that I know to come back and change it. And then leveraging Dart, really important, right? Dart as a language has fantastic features, right? It's also coming up with a lot of new features. Macros, if you've heard about, is the new big thing, right? They are building stateful widget ka macros. So instead of defining those two classes and messing up, just declare mark a widget as stateful, right? So a lot of useful things there. So using parameters, right? Dart has named parameters, required parameters, positional parameters. So understanding those three and using them appropriately, right? Named constructors is a fantastic feature, right? You can have constructors with default sets, multiple constructors with default sets, उनको अलग-अलग नाम दे सकते हो. Pattern matching is again something that I wanted for a long time. Use const everywhere. सबने सुना होगा, ऐसा मम्मी पापा बोलते हैं कि const use करो, but it really helps, right? Does not help on an individual level, but if you have an app that has thousands of screens, having const in hundreds of places, right, really makes sense. And enums, again, typed code, guys, enums, right? So use enums a lot. Enhanced enums hai, so you can use. I have built entire features based off of enums. So data encoded into the enum. I pass an enum onto a widget, and that widget knows क्या data render करना है, click करे तो क्या करना है, all those things, right? Because of these enums. And yeah, that's my time, guys. This is my contact details, right? You can contact me here if you want. And yeah, thank you. I'll hand it back to you guys.